Okay, moving on to the second half of the worksheet, starting with number 11. They want us to use what you know about special right triangles to find the area of each regular polygon. Leave your answer in simplest form. In other words, don't round. So a few things you need to know for this part of the worksheet. This is just for a regular polygon where all these sides and angles are congruent. So you need to know that the radius, it bisects each interior angle. Okay, so if I draw a radius and start at the center of the circle and I have an interior angle right here, I can draw a radius from the center to the vertex. Okay, and this angle right here is going to be congruent to that angle right there. So this interior angle is actually bisected or cut in half. Another thing you need to know, and this is for a regular polygon, the sum of the interior angles is going to equal n minus 2 times 180. Okay, so we've done that in the past, and we're going to need this to find the measure of each angle. So for the sum of each interior angle, you take the sum of all the interior angles and you just divide it by n, the number of sides. All right, so we're going to use this to find each interior angle. Okay, you also need to know the formulas for special right triangles. So this one here is a 45, 45, 90 triangle. Okay, you go across from the 45-degree angles, and each of those side lengths are called legs. Okay, so you go across from this 45 and that 45, you go from angle to side, and that's a leg. Okay, and across from the 90 angle, as we already know, that is the hypotenuse. All right, so 45, 45, 90, leg, and hypotenuse.
Excuse this interruption.
So if you recall, for the 45, 45, 90 triangle, the hypotenuse is radical 2 times as long as each leg. So you need this formula, hypotenuse equals leg times radical 2. That is for the 45, 45, 90 triangle. Now, if you recall the other type of special right triangle, the angle measurements are 30, 60, and 90. Okay, as usual, you go across from your right angle to the side, and that side is your hypotenuse. Okay, now the other side lengths are different from each other, so we can't just call them leg. Okay, the one across from 30 is going to be shorter than the one across from 60. So if you go from angle to side, that side is considered your short leg. And if you go from angle to side across from 60, that side is considered your long leg. All right, so there's actually 2 formulas based on the short leg. And if you recall, the hypotenuse is going to equal the short leg times 2. And the long leg is going to equal the short leg times radical 3. Okay, so you need these 2 formulas for the 30, 60, 90 triangles. Okay, back to the worksheet. You want to remember that each polygon is a regular polygon, so each side and each angle is congruent. All right, let's look at number 11. We have a regular triangle. Okay, we know the sum of the interior angles of a triangle equal 180. So we know that each interior angle is just going to be 180 divided by 3. So that's just 60 degrees. Now the formula for the area is 1/2 apothem times perimeter. Okay, we have the apothem, but we need each side length to find the perimeter. All right, and we said before, and I'll write it out again, that the radius, okay, this right here, when it goes from the center to a vertex, that's a radius. All right, and we said before that the radius bisects each interior angle. All right, so if each interior angle is 60 and the radius cuts it in half, this one right here is just going to be 30 degrees, and this one right here is just going to be 30 degrees. All right, now I'm going to draw in the apothem. Recall that the apothem goes from the center of the circle to the center of one of the sides. So I'm just going to draw this in right here, and it is perpendicular, or makes a right angle, with one of the sides. All right, so this 18 is the radius. I am going to write the 18 over here so you can see it better. All right, so this 18 was given, I just rewrote it. And if this angle is 30, and this angle is 90, this angle right here has to be 60. All right, 30, 60, 90. So you go across from your right angle, and that 18 is your hypotenuse. Okay, you go across from 30, and that is your short side. Okay, and we said this was the apothem, so the short side equals A. And across from 60 is your long side. All right, so I'll just leave it as long. All right, so we have two formulas. Hypotenuse equals the short times 2. All right. Remember, you have to use the formula for the side length that's given. We're given the hypotenuse is 18. So that's why I'm using the one with hypotenuse in it. Okay, the hypotenuse is 18. The short side is your apothem A, and that's times 2. The opposite of times 2 is just divided by 2. So 18 divided by 2 is 9, and that's your apothem A. All right, so this equals 9. Now, for the long side, we're going to use the other formula that we know. We know that the long side equals the short times radical 3. So we said the short side was the apothem. That was 9. And that's times radical 3. So the long side is 9 radical 3. Okay, so that is just, I'll highlight it in yellow. That is just this side right here. Now remember, we said the apothem goes right to the midpoint. So that means that this segment is congruent to that segment. So if this is 9 radical 3, that's also going to be 9 radical 3. All right. So to get the whole side, we just do 9 radical 3 times 2. All right, so each side is going to equal 9 radical 3 times 2. Okay, 9 times 2 is 18, and we still have radical 3. So that's S, each side. All right, and now we're in business. All right, we know the area for the regular polygon, it's 1/2 apothem times perimeter. And that's going to be 1/2 apothem, and perimeter is number of sides times each side length. Okay, so that's going to be 1/2. Apothem we said was 9. Number of sides n, well, it's a triangle, so number of sides n is just 3. And S we said for each side was 18 radical 3. All right, simplifying, these are all numerators except for the 2. 18 divided by 2 is just 9. Okay, and now we have all numerators. 1 times 9 times 3 times 9. I'll do 9 times 3 times 9 and then add radical 3. 9 times 3 times 9, I get 243. And we still have radical 3 left over. Final answer. There weren't any units, but if there were, the units would be squared because it's an area. Okay, please pause and try number 13, and I'll give you a hint. You want to take an apothem, go from the center of the circle to the circle itself. You're going to make a right angle here. Okay, and then when you go to one of the sides and draw in the radius. Remember, for the triangle, for the regular triangle, each interior angle is 60. So this bisects the angle into 30 and 30. All right, and this apothem bisects the side. So the whole thing is 10. This is 5 right here. Okay, see if you can finish that one, please. All right, so if you go from the center to the midpoint of the side, that's your apothem A. Okay, if this angle is 90 and this is 30, then this one here has to be 60. All right. So you go across from your right angle. That's your hypotenuse. You go across from 30, and that's your short. And finally, you go across from 60, and that's your long side. All right, the long side is the one that's given, so that's the formula we need to use first. And we said the long side is the short times radical 3. Okay, the long side is 5, and that equals the short side, which is A, times radical 3. Solving for the apothem A, the opposite of times radical 3, is divided by radical 3. All right, it cancels here. So we don't have to put this in simplest form yet. I know there's a square root in the denominator, but that's okay for now. So the short side A is going to be 5 over radical 3. Okay, that's your apothem A. And now we're in business. Okay, we said the area for a regular polygon, it's 1/2 apothem times perimeter, which is 1/2 apothem times n, the number of sides, times s, each side. We see right here it was given that s equals 10. Each side is 10. Okay, so that's going to be 1/2 times the apothem, which we said was 5 over radical 3, times n, the number of sides, which we said was 3, times s, which is each side length, which we said was 10. All right, let's see. These are all numerators and these are denominators. 10 divided by 2 is 5. And in the numerators, we have 1 times 5 times 3 times 5. 5 times 5 is 25, times 3 is 75. And the only thing in the denominator is radical 3. Okay, so there's your answer, but we're not supposed to have square roots in the denominator. The way to get rid of it is to multiply the denominator over itself. So radical 3 over radical 3. This right here is just 1, so it's just times 1. It's not changing anything. On top, we have 75 radical 3. On the bottom, radical 3 times radical 3 is just 3. Final answer. All right, let's look at number 12. We're going from the center to the midpoint here, so this right here is your apothem. Now, we have to find each interior angle here. All right, so each interior angle, it's going to be the total, which is n minus 2 times 180, divided by the number of angles, or the number of sides, same thing. So let's see, we can count sides, we can count points, 1, 2, 3, 4, 5, 6. All right, so n equals 6. I'll write it over here because I'm going to need this space right here on the top. N equals 6. So each interior angle is going to be 6 minus 2 times 180 divided by 6. So 4 times 180 divided by 6 is just 120. Okay, that's each interior angle. That's 120. So that means when we draw the radius, this angle is bisected or cut in half. So half of 120 is just going to be 60. If this is 90 and this is 60, what's this angle here? Well, that's just 30. All right. So across from your right angle, that's your hypotenuse. Across from your 30 is your short leg. And across from 60, that's your long leg. Okay. See if you can pause. Please pause and try and finish this one. Find the short leg, and then you have to multiply by 2 to get the side. All right, we're given the long leg, so we need to use the formula with the long leg. And for the 30, 60, 90, we know that the long leg is the short times radical 3. All right, the long leg is 4 radical 3. The short leg, we do not know. We'll just leave it as short. And that's times radical 3. The opposite of times radical 3 is divided by radical 3. Okay, it cancels here, and it cancels here as well. So the short leg is just 4. All right, so this right here is just 4, and this is half of the side, right? We want the whole side, So we just multiply the 4 times 2. All right, so each side is just going to be 4 times 2, which of course is 8. And now we're in business. The area is going to be 1/2 apothem times perimeter, which is the same as 1/2 apothem times n times s. All right, so that's 1/2, and the apothem was 4 radical 3. N is the number of sides, which we said was 6. We counted that earlier. S is each side length, and we said that was 8, each side length. So that's times 8, and now we can simplify. These are all numerators except for the 2. 4 divided by 2 is just 2. And let's see. 2 times 6 is 12. 12 times 8 is going to be 96. And we still have radical 3. Final answer.